There is a number that most people know, and it is the wrong place to start, which is exactly why this begins there. 10,000 quadrillion dollars. You have seen it. It appeared in Forbes and in Popular Science and in the comment sections of YouTube videos and in the feeds of people who have no particular interest in space and will never think about asteroids again after scrolling past. It appeared in headlines attached to a NASA mission, attached to a single object orbiting the Sun between Mars and Jupiter, attached to a rock, or something that may or may not be a rock. And that ambiguity is the entire story, that a spacecraft launched in October of 2023 is right now traveling toward at a speed accumulating through ion propulsion so gradual it would be invisible if you were watching from outside. The spacecraft has been flying for 2.5 years. It will continue flying for 3 more. It will arrive in August of 2029 at the object the number describes. And what it finds there may or may not match what the number was built on. That is the shape of this story. A number, the assumptions underneath it, the gap between those assumptions and what accumulated scientific evidence actually suggests. And a spacecraft on a 6-year journey toward the moment when the gap either closes or widens into something that cannot be explained away. The number was produced by Lindy Elkins Tanton, a planetary scientist and the principal investigator of the NASA Psyche mission, in 2017. She took the estimated mass of an asteroid called 16 Psyche, a body roughly 222 kilometers in effective diameter, or approximately the width of Massachusetts, currently assessed at a mass of around 22.8, 7 times 10 to the 18th kilograms, and she assumed a composition. The assumption was that Psyche is made of the same material as iron-nickel meteorites, which fall to Earth occasionally, and which are believed to be fragments of the metallic cores of ancient, destroyed planetary bodies. She applied current market prices to the assumed elements: iron, nickel, cobalt, gold, platinum, iridium, rhenium, copper, and she multiplied. The result was 10,000 quadrillion dollars, which is somewhere in the neighborhood of 100 million times the combined gross domestic product of every nation on Earth in a single year. She then described the result as meaningless in every way. Those are her words, not a paraphrase, not a generous recharacterization of what she meant. She said the estimate is meaningless in every way. And then the estimate went everywhere. It went to Forbes. It went to Popular Science. It went to the comment sections and the feeds and the headlines, and eventually it lodged, the way large numbers lodge. Not by communicating quantity. No human mind can actually process a number that size, but by communicating a category. This object is unlike anything you have ever priced. This object is beyond the scale of human economic experience. This object is not a thing. It is a concept. And once an object has been relocated from the realm of known things into the realm of concepts, the story that follows tends to take a particular shape. The object becomes mythic. The object becomes the largest prize in the history of human wanting. The object becomes the thing that will either transform civilization or, if brought home in sufficient quantity, collapse every metal market on Earth simultaneously. None of that is science. All of it traveled faster and further than any scientific paper about this asteroid has ever traveled. The number did not spread despite being meaningless. It spread partly because of it. A number that exceeds comprehension does not inform. It stuns, briefly, and then it becomes the thing the story is about. The mission became the mission to the most valuable object in the solar system, rather than the mission to an object whose composition and origin are genuinely and fascinatingly uncertain. The story locked around the number before the science had finished working through what the number was built on. And the science has kept working quietly in journals and conference presentations and laboratory analyses, while the number kept circulating unchanged, attached to assumptions it was never careful to examine. So examine the assumptions now, not to dismiss the mission, not to argue that the science is wrong, to find out what the number was actually built on and what has happened to those foundations since the number was made. Start with where the identity of Psyche came from, because the number required an identity, and the identity came from a classification, and the classification was made in 1976 by two astronomers using the best tools available at the time, and those tools, as it turns out, were not sufficient to establish what they were taken to have established. In 1976, Ben Zellner and John Grady were analyzing the spectral and polarimetric properties of a set of asteroids. They measured the spectrum, the pattern of wavelengths in reflected sunlight, and they measured how the polarization of that light changed as the viewing angle between the sun, the asteroid, and the observer varied. They compared these measurements to patterns produced in the laboratory by different types of meteorites, and they proposed a classification scheme. Certain asteroids, those with spectral slopes and polarimetric behavior that matched iron-nickel meteorites, would be grouped as M-type. M for metallic. Psyche was classified M-type. It remains M-type in every catalog today, though the larger spectral taxonomy has evolved around it. In more recent survey work, the original M-type category was dissolved into the broader X complex of spectrally featureless asteroids, reflecting the recognition that reflectance colors alone cannot uniquely identify metallic compositions. But Psyche retains its metallic interpretation because its density and radar albedo are both unusually high, providing additional circumstantial evidence that something dense and metallic is present. The identity of Psyche as a metallic world has persisted for 50 years, but Vishnu Reddy, a professor at the Lunar and Planetary Laboratory at the University of Arizona, who has published extensively on Psyche's surface composition, has identified in plain language the central limitation of the M-type classification. Metal does not have a unique spectral fingerprint. The spectral signature of metallic iron is featureless in the visible and near-infrared, a reddish slope, moderate to high albedo, no strong absorption features at particular wavelengths, and that same featureless profile is produced by at least two other kinds of surface materials. Enstatite chondrites, a class of primitive, unreprocessed meteorite formed under strongly reducing chemical conditions, produce it. Certain sulfide-rich mixtures produce it. The absence of diagnostic features is not itself diagnostic. It is a silence, and silence does not specify what is producing it. This was understood at the time of the original classification. It was not hidden. The classification was offered as an inference based on the best available evidence, which is exactly what it was. The problem is not that the classification was wrong to be made. The problem is what happened to it afterward. When a classification is stated repeatedly, in enough contexts by enough authoritative sources, it acquires a texture that the original inference never possessed. It begins to feel like an established fact rather than a reasonable hypothesis. The caveat: this surface looks like metallic iron, and could be metallic iron, but the spectral evidence cannot confirm it is metallic iron, was present when the classification was first published. Over 50 years of repetition, the caveat dropped away. What remained in the public account, and increasingly in the shorthand of scientific communication, was a statement: Psyche is a metallic asteroid. Psyche is an exposed planetary core. That statement was built on an inference about a spectral resemblance, and the number that circulated to millions of people was built on that statement, as if it were a confirmed physical measurement, rather than a hypothesis that fit the available evidence. Now ask what gave the hypothesis its authority. Because a featureless spectrum on its own is not a compelling argument for a metallic core. What made the metallic interpretation feel not just plausible, but almost obvious, was a broader theoretical framework that was already in place. A framework that predicted exactly such objects should exist and told you what they should look like. Without the framework, the M-type classification is an interesting unresolved puzzle. With the framework, it is exactly what you would expect to find, and the question of whether Psyche is a metallic core seems almost already answered. That framework is planetary differentiation, and it deserves full attention before it is examined critically, because it is not a fragile or speculative construction. It is one of the better established processes in planetary science, confirmed by multiple independent lines of evidence across multiple worlds. And the inquiry here will not be served by treating it as something that can be doubted away. In the early solar system, roughly 4.5 billion years ago, the disk of gas and dust surrounding the young sun was accreting into larger and larger bodies. Small grains clumped into pebbles, pebbles into boulders, boulders into planetesimals of tens and then hundreds of kilometers. And as those bodies grew, something happened inside them. Short-lived radioactive isotopes, particularly aluminum-26, produced in a nearby dying star whose shockwave may have triggered the formation of the solar system itself, were decaying inside the accreting material, releasing heat. Bodies that accumulated early enough while aluminum-26 was still abundant received enormous amounts of radiogenic heating. They melted. And in a melted body, materials separate by density. Iron is heavy, approximately 7,800 kilograms per cubic meter as solid metal. Silicate rock is lighter, 2,700 to 3,500 depending on type. In a melted body large enough for gravity to do its work, iron sinks toward the center. Silicates rise toward the surface. The separation takes time, perhaps millions of years, but the physics is inexorable. Given heat, given size, given time, you get a layered body, a metallic core at the center, a rocky mantle around it, a crust on top. This is called planetary differentiation, and it is not a speculative process observed only in the theoretical literature. It is confirmed by seismic data from Earth, by lander data from Mars, by orbital measurements at Vesta, by the internal structure measurements from the Moon's Apollo seismometer network. Mars has a layered interior. The InSight lander, which operated on the Martian surface from November 2018 to December 2022, detected Marsquakes and analyzed the seismic waves produced by them. The waves changed behavior as they passed through different materials at different depths, and the pattern of those changes confirmed a crust, a mantle, and a liquid metallic core with a radius of approximately 1,800 kilometers. That is not inference from Earth analogy. That is independent measurement from another planet. Differentiation happened on Mars. Vesta, the large asteroid visited by NASA's Dawn spacecraft from 2011 to 2012, shows evidence of volcanic history, a surface rich in the products of magmatic processing, a large iron-rich core inferred from its density and moment of inertia. The meteorites known as Howardites, Eucrites, and Diogenites, which arrive on Earth from time to time and whose orbits trace back to Vesta, are the mineral products of igneous processes that require a differentiated parent body. Vesta differentiated. This is confirmed. So, differentiation happened, and differentiated bodies formed metallic cores, and the early solar system was violent enough that those cores were sometimes exposed. The collisions in the early solar system occurred at velocities and frequencies that are genuinely difficult to imagine. Bodies the size of the Moon were hitting other bodies the size of the Moon. A sufficiently energetic collision could strip the rocky mantle from a differentiated body entirely, leaving the metallic core behind, a naked iron world, orbiting the Sun, slowly cooling over billions of years. And the iron meteorites on Earth tell you this almost certainly happened. Take one of those meteorites, the Gibeon, the Campo del Cielo, the Cicote Allen, the Cape York, cut it open, polish it, etch it with dilute nitric acid. What appears is the Widman-Stitten pattern, a crystalline structure of interlocking iron-nickel bands, the alpha phase, camosite, and the gamma phase, taenite, arranged in plates that can span centimeters. This structure is beautiful, and it is diagnostic. It forms only when molten iron-nickel alloy cools at a rate of approximately 1 degree Celsius per million years. 1 degree per million years. That cooling rate is only achievable deep inside a large, well-insulated body, shielded from space by hundreds of kilometers of overlying rock. Those meteorites crystallized inside a core. They are core material. The chemical analysis of iron meteorites adds another dimension. The ratios of trace elements, germanium, gallium, iridium, gold, and others, cluster into distinct groups when plotted against each other. These groups represent meteorites that cooled in the same chemical environment, from the same pool of molten metal. They come from the same parent body. Counting the groups and accounting for what each group implies about its origin, researchers conclude that at least 50 separate parent bodies contributed iron meteorites to Earth's surface. Some estimates go higher, approaching 120 or more distinct sources. 50 to 120 differentiated bodies, each with a metallic core, each destroyed by collision. Their cores scattered across the solar system. The asteroid belt is, in this account, partly a graveyard, not just leftover rocks from failed planet formation, but the wreckage of worlds that formed, melted, differentiated into cores and mantles, and were then shattered. And in that graveyard, among the survivors, Psyche sits, large, dense, with a surface that reflects light in the way iron meteorites reflect light. A radar albedo, roughly 0.42, compared to the average of around 0.014 for most other asteroid types. That implies a near-surface composition with significant metallic content, because metallic materials are far more reflective to radar than silicate rock. The density, higher than almost any other large asteroid in the belt. It fits. Everything about Psyche fits the picture the framework draws. And when something fits a compelling picture, the human tendency is to conclude that it is that picture. The tendency is reinforced by the fact that the alternative, maintaining uncertainty, insisting on the distinction between consistent with and confirmed as, requires constant, active, effortful skepticism. That kind of skepticism is difficult to sustain when you are writing a mission proposal, when funding depends on communicating a clear and compelling scientific case, when press releases need to say something definitive, when a journalist is asking what this asteroid is made of and needs an answer that can be printed. The answer that was given for 50 years is that Psyche is a metallic world, an exposed planetary core, a surviving fragment of the deep interior of a world that no longer exists. And the answer was not wrong, in the sense that it was a reasonable inference from available evidence. But it was, and always was, a hypothesis. A hypothesis that was spoken with the confidence of a confirmed finding. And then a number was built on the hypothesis, and the number circulated as if the hypothesis were established fact. And by the time the science began finding evidence that complicated the hypothesis, the story had already locked. What the science found, and when it found it, and what it means for what the spacecraft will encounter in 2029, is what needs to be pressed on now. The first and most important complication is the density. It is the one that has been in the literature longest, documented most thoroughly, and incorporated least into public accounts of what Psyche is. Solid iron-nickel alloy, the material of which a planetary core is composed, has a density of approximately 7,800 kilograms per cubic meter. The density of Psyche, derived from a combination of mass measurements using the gravitational influence it exerts on other asteroids and volume measurements using radar and optical shape modeling, sits at approximately 3,780 kilograms per cubic meter, with an uncertainty of roughly 340 kilograms per cubic meter in either direction. Call it between 3,400 and 4,100. It depends on which measurements you use and which shape model. The ratio of the measured density to the expected density of solid iron is approximately 1 to 2. Psyche is on average about half as dense as the material it is supposed to be made of. That is not a small discrepancy. It is not within measurement error. It is a factor of 2, and it demands an explanation. To reconcile the measured density with a composition that is predominantly iron, you need approximately half the volume of Psyche to be empty space. Void. Not rock, not metal, not regolith, vacuum. A structure where roughly 50 out of every 100 cubic meters is empty. The rest solid iron, the whole held together by gravity rather than structural integrity. Think of it as a metallic asteroid-scale steel wool, or a loosely piled heap of iron boulders with as much air between them as iron, but at the scale of a body 220 kilometers across. This is where the inquiry moved from observation to physical modeling. Researchers at Brown University and Purdue University, a team led by Fiona Nichols-Fleming, working on her doctoral research, asked whether that level of porosity was physically possible in an iron body of Psyche's size. Not whether it could theoretically be described as possible in some abstract sense, but whether the actual thermal and gravitational history of a body this large could have produced and maintained 50% void space to the present day. They built a thermal model. The model incorporated what is known about the thermal properties of metallic iron, the heat generated by aluminum-26 decay in the early solar system, the timescale over which a body of Psyche's mass cools, and the behavior of hot iron under gravitational compression. The behavior of hot iron under pressure is the crucial variable here. Iron above approximately 800 Kelvin is malleable, it flows, it creeps, it deforms under sustained stress. Void space in hot iron does not persist. Gravity, applied over millions of years to a hot metallic body the size of Psyche, closes gaps. The material flows and compacts. The porosity is lost. For iron to remain 50% porous to the present day, it would need to have cooled below 800 Kelvin very rapidly enough that gravity could not close the gaps before the material became rigid. In the early solar system environment, with aluminum-26 decaying inside the body and generating heat, with the body itself generating heat through gravitational compression as it accumulated mass, rapid enough cooling below 800 Kelvin is not achievable. The timescale of thermal diffusion through a body of Psyche's mass is measured in millions of years. The body could not shed its heat fast enough to lock the porosity in place before the porosity collapsed. There is a second problem on top of the first. Even if somehow rapid enough cooling had occurred, if there existed some physical mechanism that had produced and preserved 50% porosity in the aftermath of Psyche's formation, any subsequent large impact would have undone it. An energetic impact heats the material around the impact site to temperatures well above 800 Kelvin. The hot iron flows, the porosity collapses, and Psyche has not been shielded from impacts for 4.5 billion years. The asteroid belt is not a quiet place. The crater evidence on every asteroid visited by spacecraft confirms a history of large and repeated impacts. Each one, if Psyche were mostly iron, would have been collapsing the very porosity that the pure iron hypothesis requires. The conclusion from the thermal modeling was direct and specific. A pure iron body of Psyche's size cannot have maintained 50% porosity over the age of the solar system. The physical mechanism that would allow it does not exist. Therefore, Psyche is not a pure iron body. It contains a substantial fraction of lower density material, almost certainly silicate rock of some kind, that brings the bulk average. density down from the 7,800 kilograms per cubic meter of solid iron to the 3,780 kilograms per cubic meter that measurements provide. This finding was published. It was discussed at conferences. It was incorporated into the mission's own scientific documentation. The 2024 post-launch summary of the mission's science, written by Dibb and colleagues and published in AGU Advances, describes Psyche as likely containing 30 to 55% iron metal by volume, with the rest being lower density material. 30 to 55%. At the high end of that range, Psyche is majority metal, and something resembling a core remains conceivable with heavy qualifications. At 30%, Psyche is predominantly non-metallic material with a substantial iron component, and calling it a metallic world requires extraordinary qualification. The range itself is the finding. It spans a gap large enough to contain fundamentally different objects with fundamentally different histories, and it was produced after decades of Earth-based observations using the best remote sensing tools available. The spacecraft has not yet measured the density from orbit. What will come back from the gravity investigation, combined with the precise shape model the imager will produce, will be the first real constraint on the internal mass distribution. But the pre-arrival range is already telling you something important. Nobody actually knows what percentage of Psyche is metal, not within 30 percentage points. The confident story of the exposed metallic core was built on a spectral resemblance and a density that is manifestly inconsistent with the simplest version of that story. The headline did not change. The number did not change. The story kept circulating as the science quietly documented its own uncertainty. The density problem was the first crack in the foundation. The second arrived from a direction that seems almost comically out of place until you follow it to where it leads. In 2019, researchers at Brown and Purdue, Kobe Abrahams and Francis Nimmo, published a paper with a title that sounds like something from a science fiction plot outline. The paper was titled Ferrovolcanism, Iron Volcanism on Metallic Asteroids. It proposed that metallic asteroids, as they cool after their mantles are stripped away, may erupt liquid iron onto their own surfaces. Not silicate lava, not the basaltic flows that build up volcanic islands on Earth, not the sulfurous eruptions of Io. Liquid iron, pushed toward the surface by the pressure differential between a still molten interior and a solidifying outer crust. The mechanism, as Abrahams and Nimmo described it, is a variant of the same physics that drives silicate volcanism. When a metallic body loses its mantle and is exposed to space, a quench crust forms on the surface almost immediately. A millimeter-thick layer of solid iron forms within minutes as the surface temperature plunges. That crust then insulates the interior, which continues cooling from the outside in. As the outer layers solidify, they contract slightly. The volume of solid iron is slightly smaller than the volume of the liquid iron from which it crystallized, and that contraction generates compressional stress in the growing crust. Periodically, the stress exceeds the frictional strength of faults in the crust. The faults slip, and the buoyant liquid iron beneath takes advantage of the momentary relaxation of compressive stress to push upward through dike-shaped fractures toward the surface. When it reaches the surface, it erupts. Not explosively, necessarily. Liquid iron has extremely low viscosity, orders of magnitude lower than silicate lava, so it flows quickly and spreads thinly across topographic lows, pooling in craters and basins, solidifying into thin, laterally extensive deposits of nearly pure iron. The eruptions are self-limiting. Each one reduces the pressure differential that drove it, and compressional stress reaccumulates before the next. But they recur on timescales of tens of thousands of years throughout the cooling history of the body, which may span hundreds of millions of years. The physical prediction is robust. The parameters Abrahams and Nimmo used, iron's thermal properties, its density contrast between liquid and solid, the fracture mechanics of an iron crust, the buoyancy forces involved, are well constrained from laboratory experiments and engineering data. The conclusion that ferrovolcanism occurs on cooling metallic asteroids follows from the physics with reasonable certainty. The question is not whether it happens. The question is what it does to the surface of Psyche if it did. The answer is significant for everything that follows. If Psyche experienced ferrovolcanism during its cooling history, then its surface has been resurfaced by iron flows. The original composition of the outer layers, whatever was present before the eruptions, has been coated and buried under iron. The surface that the spacecraft's imager will photograph, that the gamma ray and neutron spectrometer will measure elemental abundances from, that has been the basis of every spectral observation made from Earth for 50 years, is not the original surface. It is a volcanic veneer, a coating of iron laid down by the body's own cooling process, iron that came from inside and pooled on the outside, making the surface look like pure iron when the interior might be something very different. This explains the density discrepancy without requiring implausible porosity. If Psyche's interior is substantially rocky, if it is 30 to 50% iron by volume with the rest silicate material, and if ferrovolcanism concentrated the iron at the surface by erupting it there, then the average density of the whole body would be in the observed range. The surface would present a metallic signature to every telescope on Earth because it is coated in iron. The M-type classification would be correct as a description of the surface. It would be a misleading description of the bulk composition. It also explains the surface variation that has been observed from Earth-based radar and spectral surveys. The radar albedo of Psyche varies as the asteroid rotates, between approximately 0.22 and 0.52, a factor of more than 2. A homogeneous iron core should not vary that much across its surface. A uniform material, regardless of its scale, does not produce that degree of spatial heterogeneity in radar reflectivity. But a surface coated by ferrovolcanic iron flows, distributed unevenly, deposited in some regions more thickly than others, mixed with impactor debris and with whatever original material was present between flow events, that would produce spatially variable reflectance. The heterogeneity is predicted by the ferrovolcanism hypothesis. It is not easily accommodated by the pure iron core hypothesis. The ferrovolcanism paper was published. It was incorporated into the mission literature. The mission's 2024 post-launch summary mentions ferrovolcanism as one of the potential processes that may have modified Psyche's surface. And the headline about the $10,000 quadrillion metallic world continued. The third complication arrived in 2024, and it came from the most powerful telescope humanity has ever placed in orbit around the Sun. A team led by Stephanie Jarmack at the Center for Astrophysics at Harvard and the Smithsonian, using data from the James Webb Space Telescope, published evidence of hydroxyl molecules on the surface of Psyche. O groups, the chemical building block of water, the signature of water-related chemistry preserved in mineral form. Present, detectable, distributed variably across the surface, stronger in some regions and weaker in others. The finding creates an immediate problem for the strongest version of the metallic core hypothesis, and the problem is worth staying with long enough to feel its full weight. If Psyche is an exposed metallic core, a body that formed deep inside a differentiated planetesimal, in the hot, reducing chemical environment adjacent to a metallic core, it should be profoundly dry. The conditions that form metallic cores are conditions that drive off volatiles. Heat drives off water. Reducing chemistry transforms water into hydrogen and other species that escape. The separation of metal from silicate during differentiation involves temperatures well above the stability threshold for any water-bearing mineral. A body that spent its formative history inside a differentiating planetesimal, adjacent to its metallic core, should contain essentially no water in any form. Not trace amounts, not parts per million, effectively zero. The hydroxyl is there. A metallic world should not have it. Something needs to explain it. The geomic team proposed two explanations. The first is delivery by impactors. Carbonaceous chondrite asteroids are extremely water-rich. Some contain up to 20% water by mass, locked in clay minerals and hydrated silicates. Carbonaceous chondrites impact Psyche periodically. They have been impacting everything in the asteroid belt for 4.5 billion years. When a water-rich projectile strikes a dry surface, some of the water survives the impact and is incorporated into the surface regolith. Over billions of years of bombardment, a dry metallic surface could accumulate a thin, heterogeneous veneer of hydrated material delivered from outside. The patchy distribution of the hydroxyl signal across Psyche's surface, stronger in some regions, weaker in others, is consistent with this. Impact delivery is random in location. The result would be uneven coverage, which is what the James Webb data shows. This explanation is conservative. It is physically plausible. It requires no revision to the core hypothesis. It is the kind of explanation that a framework absorbs as a complication rather than a challenge, a footnote, an interesting surface process detail, consistent with the dominant account if you do not press it too hard. Press it, because the second explanation carries implications that are far more significant, and it has been treated in the literature with less attention than its potential importance deserves. If the hydroxyl is not exogenous, if it is not delivered by impactors but is instead native to Psyche, originating from inside the body, then Psyche formed in an environment cold enough to incorporate water into its mineral structure during accretion. That means it formed beyond the frost line, the distance from the sun where water ice is stable. In the early solar system, the frost line was estimated at somewhere between 2 and 2.5 astronomical units from the sun, 2 to 2.5 times the Earth-Sun distance. Psyche currently orbits at about 2.9 astronomical units, near the present frost line, but inward of where the early solar system frost line is thought to have been. A body that formed beyond the early solar system's frost line, in the cold outer regions where water ice condensed into solid grains that could be incorporated into accreting bodies, is not the same kind of object as a body that formed in the hot inner belt, where the rocky planets assembled. A body from beyond the frost line is a different kind of thing, with different chemistry, a different formation history, a different relationship to the processes that produce metallic cores. And critically, such a body should retain water in its mineral structure, which is exactly what the James Webb data suggests may be the case. This is not a marginal possibility. The orbital distribution of M-type asteroids, analyzed in the mission's own scientific documentation, shows that large M-type and X-complex asteroids are concentrated in the central and outer main belt, distributed more like the carbonaceous C-type and D-type asteroids, which are known to have originated in the outer solar system beyond Jupiter, than like the rocky S-type asteroids that formed in the inner belt. If that orbital distribution is telling you something about origin, if M-types formed in the outer solar system and were subsequently implanted into the main belt during the giant planet instability that scrambled the early solar system's orbital architecture, then the identity of Psyche as an inner solar system differentiated core is not just unconfirmed. It may be pointing in the wrong direction entirely. The hypothesis that Psyche and M-type asteroids more broadly represent material from the outer solar system is explicitly acknowledged in the mission's own scientific documentation, the 2024 post-launch summary, which states that most large M-type and X-complex asteroids orbit in the central and outer main belt, and that it is possible they originated beyond the main belt and were implanted there by early solar system processes. This is not a fringe suggestion made by critics of the mission. It is a competing hypothesis acknowledged in the mission's own scientific framework as requiring resolution. If that hypothesis is correct, if Psyche formed beyond the frost line, possibly even beyond Jupiter, and was delivered to the main belt by early giant planet migration, then the entire framing of the mission as a window into Earth's interior requires fundamental revision, not because the science of differentiation is wrong, because the window is pointed at the wrong object. Now hold all three complications together, not as a list of footnotes but as a pattern, and look at what the pattern implies. The density is roughly half what solid iron would produce. The thermal modeling shows that pure iron at this size cannot maintain the porosity required to reconcile the density with an all-iron composition. The surface shows compositional variation, varying radar albedo, varying spectral properties across the rotation, that a homogeneous iron core should not produce. Water-related chemistry is present on the surface of an object that formed under conditions that should have driven water away entirely. The orbital distribution of M-type asteroids resembles outer solar system objects more than inner solar system ones. Each of these findings, considered individually, was absorbed by the dominant account as a complication. The density was noted, and the porosity hypothesis was invoked. The ferrovolcanism model was introduced to explain surface variation. The hydroxyl was tentatively attributed to impactors. The orbital distribution argument appeared in footnotes in scientific papers without changing the headline. But look at what maintaining the dominant account requires when all of these findings are held simultaneously. You need to accept that Psyche is approximately 50% empty space, despite physical modeling showing this cannot be maintained in hot iron over geological timescales. You need to accept that the surface variation is not telling you about compositional heterogeneity in the interior. You need to accept that the hydroxyl was delivered by impactors and carries no information about Psyche's formation environment. You need to accept that the orbital distribution of M-types is coincidental rather than reflective of their actual origins. You need all four of those special cases at once. The alternative, that Psyche is not a metallic core in the straightforward sense the dominant account assumes, requires none of those special cases. A metal-rich body from the outer solar system, one that formed with significant rock and volatile content, that was partially processed by impacts and internal heating without achieving full differentiation, that ended up in the main belt through dynamical migration, would have the density that is observed, because its interior contains substantial rock rather than all iron. It would show surface variation, because its composition is heterogeneous rather than uniform. It would carry hydroxyl, because it formed in an environment where water was incorporated during accretion. Its orbital distribution would resemble that of other outer solar system immigrants rather than inner belt natives, because that is what it is. A ferrovolcanically coated rocky body is a different version of the same general possibility. A body whose interior is substantially rocky, whose iron component was concentrated at the surface by volcanic processes during cooling, accommodates the density directly. The metallic surface signature was produced by geological activity, not by primordial composition. The M-type classification is accurate as a description of what is there now. It is misleading as a description of what the body is made of in bulk. The critical point is not that either of these alternatives is confirmed. They are not confirmed. The spacecraft has not arrived. The measurements do not exist. The critical point is that these alternatives are equally consistent with the available data. And the dominant account is not. The dominant account, the pure metallic world, the solid iron core, the dense gleaming body worth 10,000 quadrillion dollars, requires physical conditions that cannot exist. The most commonly stated version of what Psyche is describes something that the measured density rules out, and the alternatives that are physically consistent with the measurements have received a tiny fraction of the public attention that the inconsistent dominant account has received. This is the gap. Not between science and the public. That gap is expected and manageable. Between what the science actually says and what the story built on the science says. The science says Psyche is a metal-rich object of uncertain composition, between 30 and 55% iron by volume, with a formation history and internal structure that remain genuinely unresolved and will require direct spacecraft measurement to determine. The story says the most valuable object in the solar system, the exposed core of a destroyed planet, the window into Earth's interior. Both of those things originated in the same laboratory, from the work of the same scientists. One of them traveled, the other one stayed. Before the spacecraft arrives, one more thing needs examination, because it bears directly on the question of what the mission will and will not be able to resolve. And it requires going somewhere that seems at first entirely unrelated to an asteroid between Mars and Jupiter. On the Kola Peninsula in Russia, not far from the city of Murmansk, there is a rusted metal cap bolted over a pipe in the ground. The cap is surrounded by the collapsed remnants of a concrete facility, the walls caving inward, the roof long gone. The facility once housed one of the most ambitious scientific drilling projects in human history. The Soviets began drilling there in 1970. They drilled for 22 years. When they stopped, the borehole was 12.2 kilometers deep, approximately 7.5 miles, the deepest hole ever drilled into the Earth. 12 kilometers sounds like a significant depth. In the context of the problem, it is almost negligibly shallow. The radius of the Earth is roughly 6,370 kilometers. The Kola borehole reached approximately 0.2% of the distance to the center. The Mohorovi discontinuity, the boundary between the crust and the mantle, lies at 30 to 50 kilometers depth beneath the continents. The Soviets drilled for more than 2 decades and did not reach the mantle. They did not come close to the mantle. Everything that is known about the Earth's interior, the liquid outer core, the solid inner core, the layered mantle, the temperature of approximately 5,500 Kelvin at the inner core boundary, the composition of iron and light elements in proportions that explain the observed seismic velocities, was inferred from the behavior of seismic waves, not measured directly, not touched. Inferred from waves that propagate through the Earth when it fractures along fault lines. Waves that change speed and direction as they pass through materials of different density and rigidity. Waves whose arrival patterns at surface seismograph stations around the world, analyzed over more than a century, constrain what the interior must be like for those patterns to occur. The outer core is liquid, inferred from the fact that shear waves, which can only propagate through solid material, do not pass through the region where the outer core is. The inner core is solid, inferred from faint secondary arrivals suggesting that shear waves are being generated at the inner core boundary and propagating a short distance before being recorded. The core is primarily iron, inferred from the density required to produce the observed wave speeds, combined with the cosmic abundance of iron, combined with what iron meteorites suggest about how metallic cores are composed. The inference is sophisticated. It is cross-checked from multiple independent directions. It is almost certainly correct in its broad outlines. But the word almost is doing real work in that sentence. And the Kola borehole found something that the inference had not predicted. which is instructive for exactly the reason you might expect. At approximately 7 kilometers depth, the borehole was expected to encounter the Conrad discontinuity, a seismic boundary known from regional observations, interpreted as the transition between granite upper crust and denser basaltic lower crust. The boundary was real. It existed in the seismic data. The drill reached the depth where it was supposed to be. There was no basalt. There was more granite, but granite that was fractured, heavily faulted, and saturated with water. Free water, migrating through fractures in rock at 7 kilometers depth and temperatures above 180 degrees Celsius, at pressures where the models of the time said free water should not exist. The seismic boundary was real, but it had been misinterpreted. It was not a compositional boundary between granite and basalt. It was a physical state boundary, a zone where the same granite underwent a change in its fracture pattern and thermal regime that altered how seismic waves propagated through it, without any change in the rock type itself. The framework was revised. The discovery of water at 7 kilometers in rock where it had no business being according to the models required new understanding of how water migrates through deep crustal fractures, how metamorphic reactions in hot rock under pressure can produce free water from nominally anhydrous minerals. The discovery was not a crisis for geology. It was a data point from a place where no data had previously existed, and it improved the models. Notice the structure of what happened. Inference predicted something. Direct measurement found something different. The inference was revised and the models improved. This is not a failure of the original inference. The seismic data really was showing a boundary, and interpreting it as a compositional change was a reasonable hypothesis given what was known. But the hypothesis was wrong at the specific point that mattered, and the wrongness was only revealed by going there with an instrument capable of direct measurement. The Psyche spacecraft is going there. 3 days from now, from May 12, 2026, when these words are being spoken, it will pass 2,800 miles above the surface of Mars at 12,333 miles per hour, borrowing velocity from the planet's gravity, tilting its trajectory toward the outer asteroid belt. This is called a gravity assist, and it is why the mission planners routed the spacecraft past Mars rather than flying a more direct path. The planet's gravity provides momentum that the ion thrusters would otherwise have to generate by burning additional xenon, and the xenon is precious. The ion thrusters ionize xenon gas using electricity from the spacecraft's solar panels, accelerate the ions with an electric field, and expel them from the spacecraft at high velocity. The thrust produced is tiny, roughly equivalent to the weight of a few coins pressing against your palm, but it is continuous, and it accumulates over months and years into the velocity changes needed to navigate the inner solar system. The xenon has already caused one significant scare. In April of 2025, an anomaly appeared in the primary xenon fuel line. A valve was suspected of malfunctioning, possibly restricting the flow of propellant to the thrusters. The thrusters were shut down while the team investigated. For weeks, the spacecraft coasted without propulsion while engineers at JPL in Pasadena analyzed the telemetry. The concern was not only that the primary line had failed, but that the backup line was an identical design. If whatever had caused the primary valve to malfunction was a systematic design issue, the same thing might eventually happen to the backup. In late May of 2025, the team switched propellant lines. The backup system was activated. Full thruster operations resumed on June 16th. The mission was back on track. The Mars flyby remained achievable. In February of 2026, the operations team fired the spacecraft's thrusters for 12 hours in a trajectory correction maneuver, precisely tuning the approach to Mars. The result is that the spacecraft is, as of this moment, exactly on target. Sarah Bairstow, the mission's planning lead at JPL, confirmed this in early May of 2026, noting that the flight computer has been programmed with everything the spacecraft will do throughout May. The backup valve concern has not been resolved. Lindy Elkins Tanton, writing publicly in May of 2026, acknowledged that the team is doing proactive work around the possibility that the same failure mode might affect the backup valve. The spacecraft is running on its contingency propulsion system. It is meeting its milestones, but it is carrying a known uncertainty in its plumbing toward a 6-year encounter with an object whose composition is also, in its own way, carrying known uncertainties that have not yet been resolved. The instruments that will resolve those uncertainties are on board, powered, calibrated, waiting. During the Mars flyby, they will be active. The imager will capture thousands of frames of Mars, the planet as a thin crescent on approach, since the spacecraft is overtaking it from the night side, and then nearly full-on departure as the spacecraft's geometry relative to the Sun changes. The imager team will process these frames into a time-lapse sequence. Jim Bell, the imager lead at Arizona State University, has noted that this approach geometry, high phase angle, catching Mars with only a sliver of sunlight illuminating the crescent, creates opportunities for both calibration and genuinely striking imagery. The magnetometer will likely detect the Martian magnetic field deflecting charged particles from the solar wind. The gamma ray and neutron spectrometer will monitor the cosmic ray flux, testing its calibration against a known environment. All of it is practice, preparation, dry runs for the encounter that cannot be practiced beforehand because nothing comparable to Psyche has ever been visited. The instruments that will do the actual science at Psyche are worth understanding in detail because their specific capabilities and their specific limitations are both relevant to what can and cannot be settled in 2029. The magnetometer consists of two 3-axis fluxgate sensor units mounted along a 2.15-meter boom on the spacecraft, separated by 70 centimeters. The separation is important. Having two sensors at different positions allows the team to subtract the magnetic field produced by the spacecraft itself and isolate any external magnetic field from the asteroid. The instrument samples magnetic field strength at up to 50 measurements per second, with sensitivity down to about 39 picoteslas per axis. It has been on since shortly after launch, monitoring the interplanetary magnetic field throughout the cruise, building baseline measurements of the spacecraft's own magnetic signature and of the background solar wind environment. At Psyche, the magnetometer is looking for remnant magnetism. A differentiated body with a liquid metallic core can generate a magnetic dynamo through the same convection-driven mechanism that produces Earth's magnetic field. When the dynamo is active, it magnetizes the solid material around it, the mantle rock, or in the case of an exposed core, the outer solidified layers of the metal itself.
When the body cools and the dynamo ceases, the magnetization is frozen in, a remnant field, preserved in the rock, persisting over billions of years. From orbit at varying altitudes, the magnetometer can detect this field if it is strong enough. If a strong organized dipole field is detected, one consistent with uniform magnetization of a large volume of material in the presence of an ancient planetary dynamo, the implication is direct and powerful. This body once had a liquid metallic core generating a magnetic field through internal convection.
A liquid metallic core means differentiation occurred. Differentiation means the metallic core hypothesis gains very strong support. Not proof in the absolute sense. There are scenarios involving magnetization by external fields or by impact-generated plasmas, but strong, principled support that would shift the balance of evidence substantially toward the core account. If the magnetometer finds no field, the interpretation is softer. Absence could mean Psyche never had a dynamo consistent with a body that never differentiated. It could mean the dynamo operated but the remnant magnetization was subsequently erased, either by heating above the Curie temperature of the magnetic minerals, by large impacts reheating and demagnetizing the material, or simply by the field being too weak and too diffuse to survive 4.5 billion years. Even Venus, which has a large iron core confirmed by its density and its moment of inertia, has no detectable magnetic field. Its core is not convecting in a way that produces a dynamo, for reasons that are themselves the subject of active research. Absence of a magnetic field does not prove absence of a core. It is informative but not definitive. The gamma-ray and neutron spectrometer, built at the Johns Hopkins Applied Physics Laboratory, will measure elemental abundances directly, not spectral resemblances, not inferred compositions from reflected light, actual elemental measurements, produced when the cosmic rays that continuously bombard the solar system strike the surface of Psyche and knock loose characteristic gamma rays and neutrons from specific elements: iron, nickel, silicon, potassium, sulfur, aluminum, calcium. Each element produces gamma rays at characteristic energies, and the detector can distinguish between them. The instrument will return, after sufficient integration time at close orbital altitudes, the actual elemental composition of the surface material to depths of roughly 1 meter. 1 meter, not the interior. The first meter of surface, which is the regolith, the unconsolidated layer of dust, fine fragments, and impact debris that covers the body. That is not a minor limitation here. The regolith is precisely the layer most susceptible to modification by the processes: impactor delivery, space weathering, ferrovolcanic resurfacing, that could make the surface unrepresentative of the bulk composition. If ferrovolcanism coated the surface in iron, the spectrometer will measure iron. It will be measuring what is actually there, which is iron. But the iron may be there because of a geological process, not because the whole body is iron, and the spectrometer cannot distinguish between those two scenarios by itself. To distinguish them, the elemental data from the spectrometer has to be combined with the gravity data from the radio tracking investigation. Tracking the spacecraft's orbital dynamics with extraordinary precision, measuring Doppler shifts in the radio signals transmitted by the spacecraft's communication system, received by the Deep Space Network antennas in California and Spain and Australia, will allow the team to reconstruct Psyche's gravity field to spherical harmonic degree and order 10. That means the team can map how mass is distributed inside the asteroid at a spatial scale of approximately 75 kilometers. From the gravity map, combined with the shape model produced by the imager, they can extract the bulk density, the moment of inertia, and the degree to which mass is concentrated toward the center versus distributed uniformly. A differentiated body with a dense metallic core has its mass concentrated centrally. When you orbit such a body, the spacecraft feels stronger gravitational pull when it passes over the center than when it passes over the edges, because more mass is close to the surface at the edges and buried deeper at the center. The gravity map will detect this if it is present. A rubble pile or a mixed composition body, with mass distributed more uniformly, produces a flatter gravity field. The distinction is measurable, and the gravity investigation was designed specifically to be sensitive to it. But even the gravity data, which is the deepest reaching of all the instruments, describes the mass distribution rather than the composition at any specific depth. You can know that the mass is concentrated centrally without knowing whether the central mass is iron, a denser silicate mineral, sulfide material, or some combination. Resolving the composition at depth requires combining the gravity with the surface elemental measurements, with the magnetic field strength, with the mineralogical mapping from the imager's multispectral observations. Each instrument provides a constraint. The picture emerges from the synthesis of all of them, accumulated over the 26 months of orbital operations planned between August 2029 and October 2031. 26 months at 4 orbital altitudes, 709 kilometers in the first orbit phase, then 303 kilometers, then a deep plunge to 75 kilometers, then back to 190 kilometers. The close orbit at 75 kilometers is where the gamma-ray and neutron spectrometer accumulates the counts it needs for precise elemental measurements. The intermediate orbits are where the imager builds its global coverage and where the gravity field is mapped. The full picture requires the full data set, and the full data set takes 26 months to collect. What that picture will show is, at this moment, genuinely open, not in the theatrical sense of a narrator building suspense before a reveal, in the scientific sense of a measurement that has not been made. Every statement about Psyche that exists, every classification, every hypothesis, every calculation of composition and density and value and significance was made before any instrument came within 2 billion miles of the object. It is all pre-contact. The contact begins in 2029. There is a person whose story belongs in this account before the inquiry reaches its honest limit. Not the principal investigator, not a senior researcher with decades of investment in the dominant account. Someone whose position relative to the established story allowed him to see something the established story had been missing. His name is David Cantillo, and when he did the work being described here, he was an undergraduate student at the University of Arizona, working in Vishnu Reddy's spectral analysis laboratory at the Lunar and Planetary Laboratory. He was doing something that is immediately unglamorous when described, mixing minerals in a laboratory. And that is among the most informative techniques available for understanding asteroid surface composition when it is done carefully. The technique is called laboratory spectral unmixing. You take physical samples of different minerals, different silicate types, different metal alloys, different carbonaceous materials, different grain sizes, and you mix them under controlled lighting, measuring the reflected spectrum of each mixture. You compare the measured spectra to the telescopic spectrum of the actual asteroid. You adjust the mixture. You measure again. You iterate until the laboratory mixture produces a spectral match to the telescopic observation. The composition of the matching mixture tells you what proportions of what materials can explain the light coming off the asteroid. This is not a computational model, it is a physical measurement. The minerals in the mixture really are reflecting light under the same physics as the minerals on the asteroid's surface, and the constraints on what mixtures can produce a given spectrum are real physical constraints, rather than the outputs of a model whose assumptions might be wrong. The technique is laborious. It does not produce clean answers quickly. It does not lend itself to press releases. But it is harder to argue with than a spectral model, because it does not depend on assumptions about how different minerals reflect light. It measures how they actually do. Cantillo's laboratory work eventually produced a spectral match for Psyche. The composition required to match Psyche's telescopic spectrum in the laboratory was approximately 82.5% metal, 7% low iron pyroxene, and 10.5% carbonaceous chondrite material. The bulk density implied by this mixture, combined with a realistic estimate of the porosity in a loose granular material, came out around 35% void space, well below the physically impossible 50% that pure iron would require, and entirely consistent with the physical constraints from the thermal modeling. The presence of carbonaceous chondrite material in the mixture, water-rich primitive material from the outer solar system, was an early signal. This was published in 2021. The James Webb Telescope confirmed water-related chemistry on the surface of Psyche in 2024. The laboratory spectral matching, done by an undergraduate, anticipated the Space Telescope result by 3 years. Cantillo was careful in how he described his findings. He did not claim to have disproven the core hypothesis. He reported what the laboratory matching produced, and what the physical implications of the required composition were. He described Psyche as likely a rubble pile, more modified and compositionally complex than the dominant account assumed. He was a 20-year-old undergraduate working in someone else's laboratory, publishing a result that complicated one of NASA's flagship science missions. He published it anyway, because the light told him something, and he reported what the light said. The paper appeared. It was noted as an interesting constraint. The headline about the most valuable object in the solar system continued. There is something structurally significant in Cantillo's position. He had no investment in the dominant account. He had not spent years building the scientific case for the metallic core hypothesis. He had not written grant proposals around it, or given conference talks defending it, or staked his reputation on it. He arrived at the problem from outside the accumulated consensus, mixed minerals in a lab until the spectra matched, and found that the match required something the consensus had not accounted for. The person who can see both sides of an established account is usually the person who came to it after the walls were up, and therefore never developed the commitment to those walls that makes revision feel like loss. What Cantillo found is now confirmed from 3 independent directions: his own laboratory spectroscopy, the thermal modeling by Nichols-Fleming, and the James Webb hydroxyl detection. 3 independent lines of evidence developed through 3 different methods, all pointing toward the same conclusion: Psyche contains material that a pure metallic core should not have, in quantities that a pure metallic core cannot accommodate given the physical constraints on iron's behavior at its size and age. The dominant account has not been revised in the headline. It has been revised in the scientific documentation, quietly, in the form of expanding uncertainty ranges and additional competing hypotheses, and a growing acknowledgement that the mission's primary scientific objective, determining whether Psyche is a core or primordial unmelted material, remains genuinely open. The first of the mission's 5 official science objectives, as stated in the 2024 post-launch summary, is to determine whether Psyche is a core, or if it is primordial unmelted material. Whether it is, in other words, the thing the headline has been calling it for a decade, or something else entirely. That is the mission, not confirming what the story assumed, finding out what is actually there. Go back to the number 1 final time. Not to dismiss it, to understand what it was actually pointing at, and why that thing matters even when the arithmetic is wrong and the assumptions are unwarranted, and the economist's version of its significance is technically incoherent. The arithmetic fails for reasons already established. The composition is assumed, not measured. The price applies current commodity markets that would cease to exist the moment the premise of the calculation became real. If you delivered $10,000 quadrillion worth of iron to Earth's markets, the price of iron would collapse to 0 within hours, and the $10,000 quadrillion figure would become worth considerably less than the fuel required to transport it. Elkins Tanton herself noted this explicitly. The abundance of metal would immediately render metals valueless on the markets. The number describes a condition that cannot exist. It is the price of having mined Psyche combined with market prices that would only be valid if you had not. But the number was pointing at something real. The solar system contains material in quantities that have never entered any human reckoning of resources, value, or significance. The asteroid belt alone, if even a fraction of what remote sensing suggests is accurate, contains more metallic material than humanity has extracted from the Earth's surface in all of recorded history, by orders of magnitude. The question of what that material is, metallic cores of destroyed worlds, or primitive unprocessed material from the outer solar system, or something in between, or something that does not yet have a clean category, is not an economic question in any practical sense. It is a historical question. The solar system is a record of 4.5 billion years of physical and chemical process, and the asteroids are among the least altered items in that record. They are the closest thing to original documents that survive from the first chapter of the story. Psyche is one of those documents, whatever it turns out to be. The story told about it was one reading of the document, a reading made before the document had been properly examined, using methods that could see the cover but not the text inside. The spacecraft going there is the first real attempt to open it. What is written inside has been waiting since the evening of March 17, 1852, when Annibale de Gasparis at the Capodimonte Observatory in Naples noticed a point of light that had moved against the fixed background of the stars and recorded it as the 16th asteroid in the catalogue. He was working with a refractor built in Munich, in a domed room in the hill district above the city, with gas lamps in the streets below. He did not know what the point of light was made of. He knew only that it moved, that its orbit placed it between Mars and Jupiter, and that convention required it to be given a name. He named it Psyche, after the goddess of the soul in Greek mythology, the figure depicted with butterfly wings, associated in the ancient stories with the journey into the underworld and the return. The myth of Psyche involves descent into a place where things are hidden, and a return with something that was previously unknown. The name was given by an astronomer following naming conventions, probably without any particular intention toward allegory. But the allegory fits the situation now in ways that de Gasparis could not have planned. The spacecraft descending toward Psyche is going to a place where something has been hidden not by mythology but by distance, by the limitations of spectroscopy, by the gap between the surface that reflects light and the interior where the real composition lives. What it returns with will be the first direct information about what that hidden thing actually is. It may confirm the story that has been told. It may contradict it in specific, measurable ways. It may produce data that requires new frameworks the instruments were not designed to test, because the object turns out to be something that has not yet been given a clean category. In late July of 2029, Psyche's gravity will begin to bend the spacecraft's path. The approach sequence will begin. Orbit insertion is planned for August 5th. The instruments will begin their systematic observation campaign from the first orbital altitude of 709 kilometers. The imager capturing the first resolved views of a surface that no camera has ever approached. The magnetometer measuring the field around a body that no magnetometer has ever circled. The gamma ray and neutron spectrometer beginning the long integration needed to accumulate statistically significant elemental counts. For the first time in 174 years of human attention to this particular point of light in the sky, an instrument will be close enough to measure it directly, not infer it, not classify it from a spectrum, not assign it a number built on an assumption about what it must be. Measure it. The composition of the surface will be returned in counts and spectra and elemental ratios. The distribution of mass inside the body will be carved out of Doppler data from radio signals. The magnetic history of the body will be probed by a fluxgate sensor sweeping through orbits at different altitudes. The geology will be photographed at 20 meters per pixel, at stereo angles sufficient to produce topographic maps, with 50-meter vertical resolution over more than half the surface. That data does not exist yet. It will not exist for 3 more years. And when it arrives, it will land on an audience that has been told for over a decade what to expect. The gap between what they were told and what the instruments actually measure, that gap is already open. It is built into the situation. The spacecraft is flying toward it right now. Some of what the instruments find will confirm the story. Some will complicate it. Some may invalidate its central claim. None of what happens in 2029 will change the fact that the story that was told, the metallic world, the exposed core, the $10,000 quadrillion prize, was built on a hypothesis spoken with the confidence of a confirmed finding, on a spectral resemblance that could not distinguish between several different kinds of objects, on an assumption that the object's surface represents its interior when the surface may have been repainted by volcanic iron 3 billion years ago. The science knew this. The uncertainty is in the papers. The competing hypotheses are listed explicitly in the mission's own scientific documentation. The 30 to 55% metal range, with everything that uncertainty implies, is stated plainly in the post-launch summary. The scientists were not claiming certainty they did not have. But somewhere between the paper and the press release, between the journal and Forbes, between the careful statement of competing hypotheses and the number attached to the dominant one, the hypothesis became the fact, and the fact became the story, and the story became the thing a spacecraft is flying toward, carrying instruments designed, among other purposes, to find out if the story was right. That is the honest condition of where things stand on May 12, 2026, 3 days before the Mars flyby, 3 years before the asteroid encounter, 174 years after de Gasparis looked through his Munich refractor and wrote down what he saw. Everything said about Psyche is pre-measurement. Everything circulated about Psyche, the number, the classification, the framework, the anomalies, the laboratory spectra of a 20-year-old mixing minerals until the light matched, the valve failure in the primary propulsion line, and the proactive concern about the backup, is the conversation on the other side of the door. The door opens in 2029. What is on the other side is the only question that was never answerable from here. It has been waiting since 1852, resisting every simplification offered to it, refusing to confirm the categories assigned to it by anyone who tried to identify it without going there. The spacecraft is on its way.